All right, let's jump right in. We're always talking about AI like it's a brain or a mind, right? But what if that's not the best way to look at it? What if the best analogy for where this is all going isn't biological at all? What if it's something we use literally every single day? An operating system. And this quote, this is what kicked off this whole explainer for us. An operating system manages silicon. An AI manages thought. Whoa. It's such a powerful idea, right? It's saying that AI isn't just another app or tool. No, it's something much bigger, a fundamental layer that organizes and, well, orchestrates thought itself. So the big question is, how far does this analogy actually go? I mean, is this just a cool, poetic-sounding idea, or is there something deeper going on here? Are we actually looking at what you'd call structural equivalence, where two totally different systems are somehow built on the exact same deep principles? Well, that's what we're here to find out. Okay, so first things first, let's start with the surface level stuff, the most obvious parallels. Because when you just look at them from a high level, the jobs an OS and an AI do, well, they look surprisingly similar. And check this out. Both of these systems are basically high-level resource managers. I mean, think about it. An operating system, right? It's constantly juggling hardware resources. Who gets the CPU, who gets memory, all that stuff. And an AI? It's doing pretty much the same thing, but for cognitive resources. What information to focus on, what to process next, where to put its attention. They're both like conductors of an orchestra, coordinating all these specialized parts to get them to work together. But here's where it gets really interesting. The parallels go way, way deeper than just managing resources. We're talking about fundamental design patterns, the very blueprints they use to solve the same kinds of problems. It's wild. And this is the key concept we need to unpack, structural equivalence. This isn't about just finding cute analogies anymore. Nope, we're hunting for real evidence that AI systems are, completely on their own, evolving the exact same architectural solutions that operating systems figured out decades ago. It's like convergent evolution, but for code. So, let's look at the first piece of evidence. Your computer's OS runs multiple programs, right? Each one is an isolated process. Well, guess what we're seeing in advanced AI systems? The exact same idea, but they call them agents. Each one is its own little independent reasoning loop with its own goal. Process, agent, it's the same concept. Okay, so if you have all these different processes or agents running, how do you decide who gets to go next? Well, an OS has a scheduler that decides which process gets the CPU. And a multi-agent AI? It has an orchestrator that decides which agent gets to think next. It's the exact same problem, how to share a very limited resource, which is processing time. And this last one, for me, it just hits the nail on the head. So a process in an OS can't just do whatever it wants. To access the outside world, like a file or the network, it has to make a system call to the kernel for permission. Now, think about an AI agent. How does it search the web or run some code? It uses tool use or makes an API call. It's asking a central controller for permission to take an action. It's the same pattern. The structure is basically identical. Okay, so these parallels are pretty stunning, right? It really seems like we're onto something. But there is one place, one absolutely huge area, where this whole analogy just completely breaks down. And in doing so, it shines a spotlight on one of the biggest, most critical unsolved problems in AI today. I'm talking about memory. And honestly, it's not an exaggeration to say that AI memory is stuck in the 1950s. I mean, operating systems have these incredibly elegant, sophisticated ways of managing memory, and current AI models, by comparison, they are just shockingly primitive. Just look at this table. The contrast it's just staggering. An operating system creates this beautiful thing called virtual memory. It's basically an elegant illusion that makes the computer feel like it has infinite memory. When it gets full, it intelligently swaps the old, dusty stuff onto the hard drive. But in AI, it just has this flat, linear context window. And when that gets full, poof, it just throws away the oldest information. It literally just forgets. No elegance, just brute force truncation. And this quote just sums it all up perfectly. An LLM is like a computer with a super fast processor, but no hard drive. It's got plenty of short-term RAM, but once that RAM is full, you're done. There's no long-term storage, no sophisticated memory management. And this one huge limitation, it's forcing AI down a fascinating and totally counterintuitive path for the future.
See, because of this massive memory problem, this bottleneck, AI is being forced to evolve in a way that is the complete opposite of how computers evolved. And this is the core idea of our next section, what we're calling the Great Inversion.
So what's driving this whole inversion? It all comes down to the primary constraint. Back in the day, the big problem for computers was scarce RAM. So the solution was to build bigger and bigger hardware to run our bigger and bigger programs. But for AI today, the bottleneck isn't RAM. It's the insane cost of compute. So the pressure is going in the opposite direction. We're not trying to expand the hardware to fit the AI. We're trying to shrink the AI to fit the hardware.
And this leads to a really profound conclusion, the whole punchline of this great inversion. The future isn't about building one single, gigantic, super intelligent large language model. No, the future is about building large systems of small models, a whole network of little specialized AIs, all working together, orchestrated by something that looks a lot like, you guessed it, an operating system.
And look, this isn't some far-off science fiction. The roadmap is actually starting to become pretty clear. We're already seeing tons of these smaller, specialized models popping up everywhere. So the next logical step, we have to build the cognitive OS to manage them all. And once we have that, we'll start seeing truly smart appliances, your fridge, your thermostat, with real AI built right in, not just tethered to the cloud. So if this future of small, specialized models is where we're heading, it means we have a whole new problem to solve. We have to completely rethink how we create these things. The old way, the way we made the giant LLMs, that's just not going to cut it anymore. And here's the absolute heart of it. Large language models are built. You take a massive static library of the internet, you train the model once, and then you freeze it. It's like a printed textbook. It's full of knowledge, but it never learns anything new. But these future small models, they'll need to be grown. They need to be more like a living student, a little organism that's constantly interacting with the world, learning, and adapting over its entire lifetime.
So where do we look for a blueprint on how to grow a mind instead of just building a brain? Well, we look to the only system we know of that actually pulls it off, biology. And the key principle we can steal from nature is something called a fixed-role architecture. It's exactly how our own brains are put together. Think about it. Your brain doesn't just have one giant do-everything neural net, right? Of course not. We have specialized parts, stable modules for vision, for hearing, for memory, for moving our bodies. These are like the fixed organs of the system. And here's the magic trick. By having all that stability on the outside, at the edges, it allows the central reasoning core, what we call our mind, to be incredibly free, flexible, and adaptive. That's the architecture we need to copy for AI. And all of this leaves us with one final, really critical question to chew on. For the last few years, the entire race in AI has been about one thing: scaling up, building bigger and bigger and bigger artificial brains. But what if that's the wrong race? What if the real breakthrough, the thing that changes everything, comes when we finally stop trying to build intelligence and instead we learn how to grow it?